and gentlemen, we're looking at 5.2, which is perpendiculars and bisectors. A segment ray line or plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. A point is equidistant from 2 points if its distance from each point is the same. The distance from a point to a line is defined as the length of the perpendicular bisector from the point to the line. Okay? When a point is the same distance from a line it is from another line, then the point is equidistant from the two lines. So all those things are saying the same thing. Equidistance means the same distance. Get it? Equal distance, equidistance? Okay. When three or more lines, rays, or segments intersect in a point, they call that the point of concurrency. Okay? The point that it all intersects. So if you have a triangle, it's when we use it most. If I have three perpendicular bisectors, for example, this is the point of concurrency. Okay? It bisects all of the sides, and it meets the middle. Yes?
Just put that thing over so we see the drawing.
That drawing is not for this purpose, so you don't need it. Okay? All right. Perpendicular bisector theorem. If a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay. So, perpendicular bisector converse theorem. If a point is equidistant from the endpoints of a segment, then it is a perpendicular bisector. Okay, so if we look at a triangle, okay, if we have a perpendicular bisector, these two sides have to be equal to each other. Okay? Because a perpendicular bisector has to go through the vertices, and it has to go through a 90-degree angle. Perpendicular bisector converse is just the same thing. If you have a line going through here, these two are congruent, you know that is 90 degrees is perpendicular bisector. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices. Okay, so if we were to draw a triangle, and we're going to make three perpendicular bisectors. So it cuts here at 90 degrees, it cuts right here at 90 degrees, and it cuts this side at 90 degrees. What it's saying is these three lines from the point of concurrency to the vertices are equal. Those are all equal. If you have a perpendicular bisector that cuts the sides of the triangles, so it cuts all three sides, the point in the middle is the same distance from all the vertices. Okay. Now we're going to do a lovely proof. Yes.
This one is coming off.
Yep, I know. I'm aware. All right. So, yep, and I'm going to email that to your father, by the way. Example 1. Proving the perpendicular bisector theorem. So, CP is perpendicular bisector of AB. This is the given. Alright? What else do we know since it's a perpendicular bisector? We're trying to prove that the distance between CA and CB are the same. But if we don't know that yet, we do know that a perpendicular bisector, that these two must be 90 degrees, correct? We know angle CAP and angle CPB are 90 degrees by the definition of perpendicular bisector. Angle CPA and angle CPB. Okay? We know that they are congruent then to each other. CPA is congruent to angle CPB by definition of right angles. Okay. And we know AP is congruent to PB. This is also by definition of a bisector. We know that CP is congruent to CP by what? CP is congruent to CP by reflects it.
Is that a definition of right angles?
Yes. Okay. Then we know that triangle CPA is congruent to triangle CPB by, we've got side, angle, side. Good. And then we know that side CA is congruent to side CB by CPCTC. Corresponding parts of congruent triangles are congruent. Ready to turn over for the back?
No.
Okay, I'm going to give you one more minute. Please hurry up.
Hurry.
What's a statement for number 4?
I'm done.
Definition of perpendicular bisector.
Statement.
Statement is AP is congruent to PB. All right. In the diagram, EC is the perpendicular bisector of AB, and AF is congruent to BF. Okay, so explain how we know that AC equals BC. How we know AC equals BC. A bisector means what? To cut in half. Bisect. Wow, I can't spell.
Is this a 3D shape?
Is BI?
Thank you. Bisector means cut in half. Therefore, BC equals AC. Right? If you cut it in half, they're equal to each other. Explain why F would have to be on line EC. It doesn't show that it goes through F, but how do we must know? The little arrow does help, but what other thing do we know? BF is congruent to AF.
Oh, and it goes.
Then by the perpendicular bisector converse, AF equals BF if EC is a perpendicular bisector. Okay, one more. I'm going to move it up so little it's not even going to bother you. Okay. We need to find AD. We know BD is the perpendicular bisector of AC. How would we find AD?
AB.
How would we find A to D if we know BD is a perpendicular bisector?
Because definition of
AD
bisector.
is equal to CB. So 3x plus 14 has to equal 5x. Subtract 3x. 14 equals 2x. Divide by 2. What does x equal?
7.
Is that my answer? Because I want to find AD. Is 7 AD?
No.
So I plug it in and I find that AD is
35.
Yep.
Wait, how'd you get